Hello, good morning all. Today we start with third chapter of Unit 1, third and last chapter, Internet Principles. Actually, all the concepts from this chapter that you already learned in last year in computer networks. So I just give you highlights of this chapter. So let's start with this overview of TCP IP. It is a protocol suite specifies how to exchange data over the internet by providing end-to-end communication by using different types of layers. And at the each layer, your data is broken into packets, then address, then transmitted, routed, and received at the destination. So this is the simple working of this suite. At the application layer, messages or streams, that is stream of bytes created. Then at the transport layer, these messages are split into datagrams, or by using UDP. If you are using UDP, they are considered as datagrams, and if you are using TCP, that is connection oriented protocol, then the messages are handled as segments. Then at the internet layer, they can be treated as IP datagrams, that is inserting the IP address. Then at the network interface, they are treated as network frames along with network address, that is network address of destination host. Then this whole packet, that is this whole frame, transfer to the network interface of destination host. Then one by one it get open up, and finally your message reach at the destination host. So this is the simple and basic working of this TCP IP. And in IoT, one of the major building block of is connectivity, and connectivity is highly relies on this protocol suite. Next, these are the three important protocols of protocol suite: TCP, UDP, and IP. So how we differentiate these two? These two both are the transport layer protocols, but they are working totally differently. TCP, it provides reliable connection between applications. That is, connection is established before data transmission designs. Before data transmission begins. It means what? Before sending the packets from source to destination, first there is need to make connection or establish the connection between them. That is by using the three type of segments. What? Synchronization acknowledgement. So these are the segments of connection establishment in TCP. After opening that connection only, you can send the packets between source and destination. This one is more reliable. Why? Because data is sent without errors or duplication, that is duplication of segment, and is received in the same order as it is sent. No boundaries are imposed on the data, and TCP treats data as a stream of bytes, that is stream of bytes in particular order. And opposite to this TCP, this one is UDP. It is also transport layer protocol and quite alternative to TCP. It provides unreliable connection between applications. So when your machine using UDP, there is no need to make connection between hosts. Data is transmitted link by link. There is no end-to-end connection. The services provides no guarantees because no connection, there is no guarantee of receiving the packets, and data can be lost or duplicated, and sometimes datagrams can arrive out of order. So in most of the systems, connections are used TCP protocol rather than UDP. And if you want to, sorry, when you are trying to send message from two networks, only two networks, network 1 and network 2, then it is convenient to use UDP. And when your system involves number of networks, then you always go for the TCP. And because of that, most of the IoT projects, most of the higher IoT projects are totally based on TCP. And last one is IP protocol. It is a network layer protocol and it provides datagram service between applications, and it supports both TCP and UDP. That is, it is actually responsible for inserting the address header to your datagram. IP address. It is a numerical label assigned to each device connected to computer network that uses the IP for communication. This address provides two functions: host or network address and location address. That is, address of that particular host or address of that particular network and actual destination address. Then this is the address assignment. There are two types of address assignment: static and dynamic. And in IoT, this one is highly preferred, dynamic. Static IP, permanent numeric address assigned to the host in a network. Temporary IP address assigned to the host in a network. This one is manually assigned by administrator, and this one is assigned by DHCP server automatically. It can't be changed automatically. There is need for interruption by administrator, or there is need to manually done by administrator. It gets changes automatically if connection is reset or DHCP lease expires. That is, this address is periodically provided to your machine or provided to the host by DHCP. This one is less secure because it is permanent, and this one is more secure because it is temporary. That is, it periodically get changed. So this static IP addressing is normally used in services like FTP, VPN and mail servicing. And this one is used for connecting large network to the internet and communication, like in IoT. One more address is there, that is media access control address. This can be assigned to NIC, that is your network interface controller, for use as a network address when communications within network segment. And this is the representation of MAC address. Okay. It contains hexadecimal digits. This one is unique identifier, that is identifier of that particular host, that is these first 3 bytes represent address of the host, and this last rest of the 3 bytes defines what? NIC address. Next, so when we talk about the TCP/IP protocol suite, there are two versions of IPs, version 4 and version 6. And now most of the networkings or connections are migrate from version 4 to version 6 to get the better support for communication between number of devices over the internet. So let's see the differences between version 4 and version 6. In version 4, source and destination addresses are of 32 bytes, that is 4 bytes. So 32 bits or 4 bytes. And in version 6, addresses are long 128 bytes or 16 bytes. Header includes checksum. You know this concept, checksum, that is this calculation for calculating the overall format of that packet. And version 6 header does not include checksum calculation. Version 4 includes, that is version 4 header includes different kinds of options. These options represent extra capabilities or that provide extra information about that packet. And in version 6, all the optional data in move to version 6, that is extension headers. That is options from version 6 are used as extension headers in version 6. In version 4, broadcast addresses are used to send packets to all the nodes on a subnet, that is on the same subnetwork. No broadcast addresses are used in version 6. Instead, link local scope, all nodes multicast address is used. It means what? In version 4, broadcast addressing is used, and in version 6, multicast address is used. Version 4, manual, that is static or DHCP based IP configuration, and in version 4, and in version 6 there is no need for manual or DHCP configuration. Why? Because nodes are capable of auto configuration, that is they configured itself by their own. Next, so this is the difference between version 4 header and version 6 header. Okay, see here, there is version, then header length, type of service, total length. Okay, and here is only version, and all these two are considered as only traffic class. Then there is flow label, that defines the order of bytes. Then only payload length, next header, hope limit, that is hope limit means how many routers they need to follow to reach the destination, and only source and destination. And here is number of blocks are there, like identification, then flags of fragmentation offset, this is TTL protocol, header checksum, and then source destination address, and then there is one more, that is extra options, padding bytes, like that. So this is quite complex as compared to version 6 header. And next is application layer protocols. So all these are application layer protocols. This is the type of layer or protocol they are using to provide the service, and this is their port number, and this is the use of that particular protocol. So you can get the extra information about this protocol over the Google. So just go through this point. I hope you all understood this chapter of internet networking, because you had already learned these concepts in SY. Thank you.